In this video, we're going to evaluate the integral of 3x squared multiplied by the square root of 16 minus x to the 6. And this integration here is going to involve, at least the way I'm going to do it, a trig substitution. You can probably do it without introducing a U-substitution, but just to make it more clear, I'm going to use a U-substitution to set it up. So we got 16 here minus x to the 6, and we can think of the 16 as 4 squared. And then x to the 6, I can write it as x cubed squared. Multiply the exponents so I get the same thing. And notice if I let u equal to x to the third, then du will be 3x squared dx. So notice the 3x squared, that's the product here with dx. 3x squared dx. That'll be du. And then right here, I'd have 4 squared. And then this will be u squared. So in terms of u, that's what I'm going to have. The integral of the square root of, I'll write this as 4 squared minus u squared. And then this will be du. And this is what I have right here. You can see it better when I have it typed. Ux to the third du is 3x squared dx. And then I have the integral revamped here again. Just went over that, but hopefully you can see it better here. Integral of the square root of 4 squared minus u squared du. And here I'm going to use a trig substitution that involves the sign. So here's my substitution. Sine of theta will be u over 4. Remember, u is x to the third. Solving for u, I get u equal 4 sine theta. So du is equal to derivative of 4 sine theta, which is 4 cosine theta d theta. And then I'm just going to make the appropriate substitutions here. So again, du right here is going to be replaced by 4 cosine theta d theta. And then we rewrite this back as 16 here. 4 squared is 16 minus, and then the u here is 4 sine theta. Square it, that's 16 sine squared theta. And then you take out a 16, factor out a 16, and you get 1 minus sine squared theta. But from one of your trig identities, 1 minus sine squared theta, that will be the same thing as cosine squared theta. And the square root of 16 is going to be 4, so it's going to come outside. And then the square root of cosine squared is going to be cosine. But remember, the du is going to have another 4 over here. 4 cosine theta d theta now. So that's going to give me a cosine squared, because this is the square root, so it'll be cosine. So when I plug in this right here for du, that's going to introduce a 4 and a cosine. And then from this radicand, I get a 4 and a cosine. Cosines are going to multiply, I'm going to get a cosine squared. So this integral then is going to become 16 cosine squared theta d theta. Again, the simplification of this expression here gave me a cosine squared, or a cosine rather. Cosine squared, took the square root, I got cosine. But then the du introduced another cosine, so I got a cosine squared. That's how I got this right here. And then from this right here, when I took the square root of 16, I got the 4. And then I had another factor of 4 from the du. That's how I got the 16. So now it's just a matter of evaluating this integral here. So this is going to equal to, I'm going to factor out the 16 here. And there is a formula for cosine squared theta from trigonometry. And this formula is 1 plus cosine 2 theta over 2. And this is d theta. Now, further simplification here, the 2 constant again, so I can bring it out, divide the 16. So this will be an 8 here. So now we integrate here. Integral of 1 with respect to theta here is just theta. Then it's plus. The integral of cosine is sine. And then I got a factor of 2 here because of the 2 theta. Take that, get rid of that, and that gives me a 2. So I divide that by 2 here. And then sine of 2 theta, we have an identity for that. That's sine, or 2 sine theta, cosine theta. And that's divided by 2. From this 2 right there. Then these cancel out. Then you go back up here then, and then this is equal to, still got the 8 out here. And that's going to multiply theta, and then get a plus sine theta, cosine theta. You can draw yourself a reference triangle here if you want. Okay, this is theta here. Sine of theta is over 4, so this is u here. And then there's a 4 here. And then complete the right triangle. This is the right triangle here. This is going to be the square root. 4 squared, or so you can write that as 16 minus u squared. And of course you know that sine theta is equal to u over 4. So theta then, take the inverse sine of both sides, theta is equal to sine inverse of u over 4. So this is equal to then, this will be 8. And then I'm going to replace the theta by sine inverse of u over 4. So this will be sine u over 4. But we have to go back to the original variable. So remember that u is equal to x to the third. So I'm just going to write this as x to the third over 4. And this is plus sine theta is x cubed over 4. We put it in there. And cosine theta from the triangle, cosine is square root 16 minus u squared. But remember u, again, is x to the third. You square it, you get x to the 6. And that's over 4. So this gives me 4 times 4, 16. But remember, it's being multiplied by 8 here. So it'd be 8 divided into 16. I should say 8 over 16, 1/2. So again, after multiplying 2 by the 8 here, the final answer comes out to 8 sine inverse of the u, but u was x to the third over 4, plus, and then this coefficient reduced to 1/2. At 16 here, and then 8 over here, that reduced to 1/2. And that was then the product of x to the third, and that's multiplied by the square root of 16 minus x to the 6. So this is your final answer. Thanks for watching. We'll see you next time.